Hello, my darlings. Okay, another technique for integration today. Look at this first example. Look at how messy this numerator is. The integral of 2x to the fourth plus 3x cubed plus x squared plus 12x minus 1 all over x squared plus 4. And neither the top nor the bottom is the derivative of the other. Oh my goodness, what are we going to do to simplify this so we can integrate? I have no idea. This is so messy. Well, this is where our new technique comes in. We're going to divide. And when I say divide, I mean long division. We're going to take x squared plus 4, and we're going to divide that into the numerator, 2x to the fourth plus 3x cubed plus 8x squared plus 12x minus 1. I got to expand that division sign. Because remember, a fraction is division. So, okay, x squared goes into 2x to the fourth. X squared times what is 2x to the fourth? So we use the leading term to do this division. X squared times what is 2x to the fourth? That would be 2x squared. So now remember, when we divide, we have to subtract this product. 2x squared times x squared is 2x to the fourth, and 2x squared times 4 is a positive 8x squared. Now when I subtract this, the 2x to the fourths go away. I still have a 3x cubed. The 8x squareds go away. I still have a 12x, and I still have minus 1. So again, we're going to put x squared, the leading term, into 3x cubed. X squared times what is 3x cubed? That would be a plus 3x. So 3x times x squared is 3x cubed, and 3x times 4 is 12x. And when I subtract, the 3x cubes go away, 12x minus 12x is gone, and all that's left is negative 1. So the answer to this division is 2x squared plus 3x minus the remainder 1 over, we divided by x squared plus 4, okay? Which means now I can take this and come back to my integral and rewrite it. And I'm going to break it up into two parts because I know we can take the integral of that very easily. So I'm going to do the integral of 2x squared plus 3x, and I'm going to put a dx here, minus the integral of 1 over x squared plus 4 dx. But if you look carefully, the second, remember we said the first one's easy, but the second one's not that bad. That's an x squared, and if a is 2, that's a squared. So that's just a tan inverse. So we can do this. So the antiderivative of 2x squared is 2x to the third over 3, plus the antiderivative of 3x is 3x squared over 2, minus, now if we use the tan inverse, okay, it's 1 over the a is 2, tan inverse of our x over the a is 2, and don't forget the plus c. Whew, look at all of that. And that all hinged on us doing long division first. Okay, let's try another one. So here we go. We have the integral of x cubed plus 3x squared plus 8x plus 19 all over x squared plus 5 dx. And again, neither the top nor the bottom is the derivative of the other. So we can't make a u substitution there. So we're going to do long division. X squared plus 5 divides into x cubed plus 3x squared plus 8x plus 19. Now x squared times what is x cubed? X squared times x. So that's x cubed, but x times 5 is 5x. So when we subtract this, the x cubes become 0. I have a 3x squared. 8x minus 5x is 3x. And we keep the 19. Now we're going to divide again. X squared goes into the first term, 3x squared, 3 times, because 3 times x squared is 3x squared. And we're going to subtract this, and 3 times 5 is 15. Now when we subtract, the x squareds add to 0. I keep the 3x, and 19 minus 15 is 4. Now, x squared, the degree here, x squared is bigger than the degree of our remainder, so we're done dividing. So the answer to our division is x plus 3 plus 3x plus 4 over our divisor, x squared plus 5. Now, if you look at that fraction, 3x plus 4 over x squared plus 5, again, neither the top nor the bottom is the derivative of the other. We're going to need to split this up a little bit. We're going to go a step further and say that this is 3x over x squared plus 5 plus 4 over x squared plus 5. Now we'll be able to integrate. Okay, so let's see what happens when we do this. So the first thing I'm going to do is I'm going to take the integral of this first part. Integral of x plus 3 dx. Then I'm going to take this one plus the integral of 3x over x squared plus 5. Then I'm going to take this one. Oops, I forgot my dx there. Can't lose that. Now I'm going to take plus the integral of 4 over x squared plus 5 dx. Now here's the thing. I know we can integrate the first integral very easily, quickly. We're not going to do that because each time you integrate a part of this, you would get a constant. You don't want to have a plus c plus c plus c. You only want one constant all at the end. So if we integrate at the same time, we can do one constant other at the end. Otherwise, for the pink integral, we have to have a plus c1. For the green integral, we have to have a plus c2. For the purple integral, we have to have a plus c3. And then we add them all together, and all three of them together become a plus c4. That's crazy to have 4 integrals. It's easier to wait. Now, I know we can do the antiderivative x plus 3, not a problem. Now, this middle one, if you look at this 3x over x squared plus 5, this is going to require a u substitution. U would be x squared plus 5, and du would be du over dx would be 2x, which means du over 2x is our dx, okay? So now I'm going to start rewriting. We're going to have the integral of the quantity x plus 3 dx. Then we have plus the integral of 3x over, now this x squared plus 5 is my u, and my dx is du over 2x. And then I still have now my third integral. That 4 is a constant, and if I look, that's my x squared, and my a squared is 5. That would be a tan inverse. So that's 4 plus the integral of 1 over x squared plus 5 dx, where this a is the square root of 5. All right, now let's start. Oh, we still have to simplify, so I'm going to rewrite again. The integral of x plus 3 dx plus, now the x's are going to cancel out, but we have a 3/2 times the integral of 1 over u du plus 4 times the integral of 1 over x squared plus 5 dx. Now we're ready to take the antiderivatives. The antiderivative of x is x squared over 2. The antiderivative of 3 is 3x. Then we have plus 3/2. The antiderivative of 1 over u du is the natural log of the absolute value of u. Okay. Plus 4. And then this antiderivative, 1 over x squared plus 5, is the tan inverse, which follows the pattern 1 over a, which is the square root of 5, times the tan inverse of the x over the a is the square root of 5, plus our constant. All right, we're almost done. We're going to simplify this and resubstitute. We have x squared over 2 plus 3x plus 3/2 times the natural log of the absolute value. Wait a minute, what was my u? My u was x squared plus 5. close that absolute value, plus 4 over the square root of 5, tan inverse of x over the square root of 5, and don't forget that plus c. Wow, that's a big one. And there we go, guys. So that is how we utilize long division to make the integrals simpler. That looks simple, doesn't it? Okay, I know it's a messy looking answer, but if you take it piece by piece, it's not that bad. All right, guys, I promise we will be practicing that, and I will see you soon. Have a great day.